Okay, now check this one out. It's the same idea as before, but what we're trying to do is play with this idea here. The last two examples went something like this. 1 over x from 1 to infinity dx, that turned out to be infinite. And then we did integral from 1 to infinity of 1 over x squared dx, and that turned out to be equal to 1. And now we're contemplating the question, what happens if you take something in between here? What happens if you were to take the integral of 1 over x to the 1.5 from 1 to infinity? This exponent here is 1. This exponent here was 2. And this one was infinite and this one was finite. What would happen if you take something in between, like 1.5? That's exactly this one. This one becomes the integral of 1 over x to the 3/2 from 1 to infinity. With respect to x, that would of course become the integral from 1 to infinity x to the negative 3/2 dx, which would become x. You add 1 to the exponent, you divide by the new exponent, and you go from infinity to 1. If you draw an indeterminate, go back and use your limits. If we don't, we're good. Negative 2 over the square root of infinity minus negative 2 over the square root of 1. I reckon that's negative 2 over infinity minus 2 plus 2. I reckon that's equal to 0 plus 2. That's equal to 2. Picaye. See that? This one turned out to be equal to 2. It's in between these guys, in between 1 and infinity. Nice, huh? It gets interesting. Alright, this one's still kind of an easy example. I think if you do a few of these, you get the pattern here. Which ones we're going to go to infinity and which ones are going to go to some number, some finite number. But I'll let you explore with this. Try something in between these two, or try something in between these two and see what happens. In between where the exponent here is 1 and 1.5. And try something between 1.5 and 2. And you'll get the hang of it. Alright, come back for some more awesome examples.